Hello everyone. In this video I will make an introduction to second section, second derivative test for concavity and finding inflection points. Okay, what is inflection point? Inflection point is a point where function changes its concavity. It changes its concavity from concave to convex or convex to concave. We have an inflection point at c f of c, let's say, where second derivative is either 0 or undefined. So as in the critical values, the function also should be defined at that c point. Otherwise, it's not considered to be an inflection point. Okay, let f be a defined function at x equals c. Then cf of c is inflection point where second derivative is either 0 or undefined. And concavity of the graph also must change. Otherwise, not otherwise it's not considered to be an inflection point. Okay, we can say there is whenever there is an inflection point, either second derivative is 0 or undefined, but the opposite is not always true. We cannot say second derivative is 0, so there is a point of inflection. No, it doesn't have to be. Let's say second derivative is undefined and we cannot say there is a point of inflection, so concavity is not changing, then there is no point of inflection. So whenever there is point of inflection, second derivative is either 0 or undefined. The opposite is not always true. Test for concavity. So there's a relation between signs of second derivative and the concavity of the function. If second derivative, the sign of second derivative in a region is negative, then function is convex. It's opening down. If second derivative sign is positive, then function is opening up, which is called concave. Okay, convex opens down, concave opens up. So we are going to be using this table a lot to solve questions. So this table actually is called second derivative test. So we're gonna make table of variations and figure out the regions which function is concave and convex. Let's take a look at two ministry questions, the same question. Use the graph below. At which value of x f double prime is less than 0? What does f double prime being less than 0? If derivative, second derivative is negative, look at the table, then function should be convex. So we are looking for opening down part. So which part is opening down in this graph from starting 0? 0 is change of inflection, point of inflection. This is where concavity changes. So from 0 to infinity is opening down. 0 to infinity. So in this region, the function is convex. In other words, second derivative is negative. All right. So let's take a look at some exercise questions. Exercises 2 and 3. Identify concave and convex intervals. Concave means opening up part. So graph is opening up from negative infinity until this point. This is where the concavity changes. So from negative infinity till 1, it's concave. We never include brackets to determine increasing, decreasing, or concave convex intervals. Convex interval, this is where function is opening down. Function is opening down from 1 to positive infinity. All right. Exercise 3, let's do the same. So this part is opening up. This part also opens up. So we have two parts opens up, meaning concave. So what are the concave intervals? From negative infinity till I see a vertical asymptote here. Even though it's invisible, it's not given in the question. It is clear that we have asymptotes here at negative 1 and 1 because this is where function is approaching, right? This part is approaching this way, that part is approaching the same way. From negative infinity till negative 1, union, the second part from 1 to infinity. This is concave interval. Convex interval, the opens down part between two vertical asymptotes. It's stuck between two lines, which are negative 1 and 1. Alright, so this is how we identify concave, convex intervals from the graphs. So in the next video, I'll explain how to find each interval, concave, convex interval, from the functions by solving the questions.